In this video, we're going to look at mixed transformations. So we're putting together the translations that you studied a lot in Algebra 2, along with the stretches and compressions and reflections that we're learning about now. Our first function, the parent, is our cubic function. So the transformations are any multiplication or addition or subtraction. Powers are never a transformation. Powers indicate the parent function. All right, we'd see multiplication on the outside, not grouped with the x, so that is a vertical stretch or compression. The value is between 0 and 1, so that is a vertical compression. Inside, grouped with the x, we see a -6, so that shifts the graph opposite from what we think, because that's in the asylum grouped with the x. It looks like it's going left, but it's right 6. And then on the outside, we have that -7, so our graph is going down 7. The shifts or the translations do affect that critical point. We're going right 6, down 7, so that's our critical point. Our cubic function is an easy one with domain and range. No matter what the transformation, we get all real numbers for domain and range for cubic. Second example, this parent function, notice we have an x in the denominator. There is no power on it, so this is our regular inverse function, not the inverse square. Taking a look, we have a lot of transformations. First of all, I see that negative being multiplied. It is not grouped with the x, so this would be a vertical reflection. In the denominator, now the fraction bar is a grouping symbol. So we've got that 2 in the denominator being grouped with the x. So that is a horizontal stretch or compression. Because it's bigger than 1, we would think it's a stretch. But when it's grouped with the x, it does the opposite of what we think. So this is a compression. Also grouped with the x in the denominator is that +1. So we would think it's going to the right, but it's going left 1. Does the opposite of what we think. And then finally on the outside, not grouped with the x, is that +3. So our graph is going up 3. That changes our critical point, shifting it left 1 and up 3. For our inverse function, the domain and range are based around what are called asymptotes. So for the parent function, the asymptotes occurred along the x and y axis. Notice that 0, 0 is not a point on the graph. It's the point where the asymptotes meet. So for the domain, when we shift the graph left, that changes it from x cannot equal 0 to x cannot equal -1. When we shift the graph up 3, that changes the range from y cannot equal 0 to y cannot equal 3. So notice that critical point is giving us our domain and range for our inverse function. One final example, we have a lot going on with this step function here. First of all, we have that 2 being multiplied outside, not grouped with the x. So that is a vertical stretch. It is normal. It does what we think it should because it's outside the asylum. Inside, grouped with the x, we have that negative sign. So that is a horizontal reflection. It's horizontal because it is grouped with the x. Just like that -3 is a horizontal shift. It looks like it's going left 3, so that means it's really going right 3. And finally, we have that -2 on the outside, so it's also going down 2. Again, those shifts change the critical point of the function. We shifted the graph right 3, down 2, so that's our new critical point. The domain for the step function is still all real numbers, and we did have a vertical stretch. The vertical stretch will impact the range because instead of stepping up by 1, that vertical stretch says we're now stepping up by 2. So our range will be even integers.